Hello, let us talk about set equality. We say that two sets are equal if they are subsets of each other. That is to say, A is a subset of B and B is a subset of A. Now, we say that A is a subset of B if all elements of A are also elements of B. So we are saying all elements that belongs to A are also elements that belongs to B. Okay. Now, the first example, we want to show that the complement of a set is a subset of a set. So I will demonstrate it on the Venn diagram first. So given that this is set A, okay, what is the complement of A? So the complement of A is this side. All right. So if an element is not in A, meaning that it is in a complement. Okay. Now, what if the element is not in a complement? It means it is in A. So now, if this is a complement, meaning that this is a complement. Okay, so how do we write this mathematically? We say let x be in a complement. So an element x is any element x is in a complement. So what does this imply? This implies that x is not in a complement because x here is in a complement, meaning that it is not in a complement. So what does this imply? This implies that x is in a. Okay. Now we picked x in a complement, and we found that x is in a. So therefore we say that a complement is a subset of A. The next thing we are going to prove is the famous De Morgan's law. So De Morgan's law, um, the first one states that the complement of intersection is just the same as the union of complements, or you can say the complement of unions is the intersection of complements. So to prove this statement, we are going to show that the complement of intersection is the subset of the union of complements. The other direction is to show that the union of complements is the subset of the complement of intersection. We are going to show one direction, and the other direction I leave it as an egg. Before we proceed with our proof, we are going to demonstrate this on a Venn diagram. So first of all, let us shade the complement of A intersection B. So if the middle part is A intersection B, then its complement are just elements that are outside. Okay. Now let us see if it is the same when we take the unions of complements. So first of all, let us shade a complement. So a complement is everything that is outside here. Okay. Now, what is B complement? So B complement starts from here. Everything that is outside here. What is the remaining part? You can see that the only remaining part that is not shaded is the middle part, okay? Where the unshaded region is the complement of A intersection B or A complement union B. Now, how does it go if you have arbitrary elements? So first of all, we are going to say let X be an element of A intersection B complement. So we want to show that if we pick an element in A intersection B complement, we can also find it in A complement union B. Okay. Now, if X is in the complement of A intersection B, it means that X is not an element of A intersection B. What does this mean? This means that X is not in A and X is not in B. So if X is not in A and not in B, what does that mean? It means X can be in A complement or X can be in B complement. All right. Now let us combine this together. Remember, all means union. So mean that X is in A complement union B complement. So we picked an element X in the complement of intersection. We found that this element is in the union of complements. So therefore, A intersection B complement is in A complement union B complement. I leave a task for you to show that A complement union B complement a subset of A intersection B complement.